Section 11.5 focuses on the combined gas law, and the combined gas law combines all three of the gas laws that we previously talked about in the other videos. The combined gas law combines the simple gas laws, Boyle's, Charles, and Gay-Lussac's laws, okay? Boyle's, Boyle's, Charles, and Gay-Lussac's, okay? So the formula for the combined gas law is as follows, okay? P1 times V1 over T1 equals P2 times V2 over T2. You still have your initial conditions and your final conditions. Okay, now let me show you something. Looking right here. If you hold constant the temperature, you have Boyle's law. P1 V1 equals P2 V2. If you hold pressure constant, what do you have? Charles' law. V1 over T1 equals V2 over T2. And if you hold volume constant, what do you have? Gay-Lussac law. P1 over T1 equals P2 over T2. So you combine those gas laws together and you have the combined gas law. You need to remember again with the temperatures to have them in Kelvin. And sometimes you have this term STP come up when you're doing combined gas law problems. And what this means, STP, standard temperature and pressure. And it refers to the following conditions for temperature and pressure. It refers to a temperature of 0 degrees Celsius, which we automatically would use the Kelvin equivalent, 273. And the pressure that it equates to is the standard 1 atmosphere of pressure. So in a word problem, when you see conditions of STP, right away, conditions of STP equate to that temperature and that pressure. Okay, let's do a problem with the combined gas law. I think there's a problem in the extra credit assignment. Yeah. That this would help you out with, okay? Okay. I guess with a volume of 3.50 cubic centimeters, has a pressure of 2.50 atm at a temperature of 55 degrees Celsius. What is the volume when the gas conditions are adjusted to STP? Okay. So this is the combined gas law. You say, well, how do I know all these gas formulas? Okay, look at the units. Cubic centimeters. We haven't heard that one in a while since we did our density lab experiment 2. This is a unit for volume. Remember, your cubic centimeters, cubic meters, they are units for volume, metric units for volume, just as liters and milliliters and all the other variations of the liters, okay? We have here atmosphere, that's a pressure. We have Celsius, that's a temperature. What is the volume when the gases conditions are adjusted to STP? You say, okay, where do we start off with? Well, just like the other gas laws, we need to have the temperature in Kelvin. So we need to convert Celsius to Kelvin. 55 degrees Celsius, we're going to add 273 to get it into its Kelvin equivalent. So that would come out to 328 Kelvin. Okay, now what we want to do, STP, that's representative of two numbers. Temperature of 273 Kelvin and pressure of 1 atmosphere. There are two numbers that you're going to plug into your equation when it comes time to set that up, which we are at right now. Set up. P1 over P1 times V1 over T1 equals P2 times V2 over T2. Let's look at what we have. Do we have the initial pressure? Yes. 2.50 atmospheres. Do we have the initial volume? Yes. 3.50 cubic centimeters. Do we have the initial temperature? Yes. 328 Kelvin. We have all of the initial conditions given to us. What are the final conditions now? The second part of the equation. Well, the second part of the equation is adjusted to STP. Okay, well, do we have that final pressure? Yes, that's standard pressure, 1 atmosphere. Do we have the volume? No, that's what we're asked to find. Okay, this is what we do not know. That's a question mark, okay? Do we have the final temperature? Yes, we know it was adjusted to standard temperature, 273 Kelvin. Okay, now we need to find V2. So we have this here, and we need to manipulate this equation to solve for V2. Well, that's where cross multiply comes in really handy. If you want to use your reciprocal math that you learned prior in an algebra class, go ahead if you like that way, but I'm going to show you cross multiply. It really makes things simple when you're doing the gas laws to cross multiply. Okay, so let me just divide this up here. Okay, so cross multiply, remember this numerator times this denominator. This numerator times this denominator is one side of the equation. The other side of the equation is the product of this denominator times this numerator. Let's write that out. 2.50 atmospheres. Make that neat. Times 3.50 cubic centimeters times 273 Kelvin. That is one side of your equation, okay? I'm going to underline that in red because that's the product with the red arrow. Equal to the other product, 328 Kelvin times 1 atmosphere times V2. That's your other side of the equation. That's a result of this cross product here, okay? Now we need to solve for V2. Okay, but before we solve for V2, just to reiterate again where this is coming from. Cross multiplication. We just have some more numbers now than we did when we had Charles' law and Gay-Lussac law. 2.5 times 3.5 times 273. That's one side of your equation. Equals the product of 328 Kelvin times 1 times V2. Now our variable is the volume. So we need to divide both sides of the equation by whatever V2 is being multiplied by. Okay, now it's just an algebra problem. 328 Kelvin, 1 atmosphere. What we do to one side of the equation, we need to do to the other side of the equation. That all cancels out, cancels out. Now, if we look over here, units that are similar and cancel out. Kelvins cancel out. Atmospheres cancel out. And we're left with units of cubic centimeters, which are appropriate units for volume. Okay, now you need to get this answer. When you put it into your calculator, you need to take this product and divide it by this product. Now, we luck out with the denominator having something multiplied by 1, so it shouldn't really give us, it really won't affect our answer with this. But good practice is to use the parentheses, because don't just assume that your calculator is going to do what you want it to do. Okay, you need to tell it, take this product and divide it by this product. So 2.5 times 3.50, or sorry, 2.50 times 3.50 times 273, that product divided by the product of 328 times 1. Okay, now yes, I know that the 1 doesn't make a difference with this example, but if you had another pressure there that was not 1 atmosphere, then you would have to make sure that you have those parentheses there in that denominator so that the math is calculated correctly. What do you get? You get a resultant volume of 7.28 cubic centimeters. Okay? For your final answer. Okay? So this problem here should help you out with doing the extra credit problem with that involves the combined gas law, except the extra credit problem a little bit different, okay? So it's not, it's using this gas law, but that's all I'm going to tell you, okay? You'll figure it out, okay? Look over this example and use that as your guide.